Trigonometry. 4 goals under trigonometry. First one is to be able to evaluate trig expressions, and in videos that are going to follow we'll deal with B and C, which is trig equations and identities, and then the final 1 or 2, depending on how long it takes, we'll deal with graphing. So we're going to focus on trig expressions right here. We're going to start out a little quick review of trig. We've got all of these things are in degrees: 0s, 30s, 45s, 60s, 90s. 30, 60, 90, a quick review. Throw our triangle in there. If there's my 31, there's my 60, root 3. There's my 92. And while we're at it, 45, 45, 90, isosceles right triangle, 1, 1, root 2. And if we want to deal with the zeros in the 90s, we could always deal with, those are called quadrantal angles. I like to do the north, south, east, west with the unit circle, and say the unit circle would have a radius of 1, so that's the point 1, 0. This is the point 0, 1, and we could work our way around that unit circle. Again, remember, with the x-coordinate being the cosine and the y-coordinate being the sine of those quadrantal angles. So here we go. So if we want to deal with zeros, sine of 0 is going to be the y-coordinate, going to be 0. Sine or cosine of 0 is going to be the x-coordinate, going to be 1. Jumping to 90 degrees. Sine of 90 degrees, again, y-coordinate is going to be 1. Cosine of 90 degrees is going to be 0. The 30s and the 60s. So sine of 30 degrees, opposite over hypotenuse. Sine of 30, 1/2. Cosine of 30, root 3 over 2. Sine of 60, root 3 over 2. Cosine of 60, 1/2. And then the 45s. On the 45s, sine and cosine, they're both the opposite and the adjacent are the same, which is we're looking at 1 over root 2, or you certainly could rationalize it if you wanted to and call it root 2 over 2, but you're going to find in calculus it doesn't matter whether you rationalize the denominator or not. Tangent. Well, tangent, very simply, take the two values above. Tangent is the sine of theta divided by the cosine of theta. So the tangent is 0, sine over cosine is 0. Tangent of 30, 1/2 divided by root 3 over 2, or 1 over root 3. Tangent 45, those values are the same, which means we're looking at 1. Tangent of 60, root 3 divided by 1. Tangent of 90 won't exist because you're trying to divide by 0. There's a little quick review of dealing with some trig identities. Now let's give some of these values simplified radical form. Now that does not mean that you have to rationalize a denominator, but what we're really looking for here are two things. I need to come up with a quadrant, and I need to come up with a reference angle. If you can come up with those two things, you can handle any trig problem. So 135 degrees, 135 degrees. Let's see, if we quickly drew an angle of 135 degrees, it would look something like this. Well, what does that mean? Well, that means we're about 45 degrees short of the horizontal, which means that 45 is my reference angle, and up above a second ago I drew you a 45, 45, 90 right triangle, 1, 1, root 2. So we're in quadrant number 2, which means sine is going to be positive, and we're looking at the sine of that 45 degrees, so 1 over root 2, positive 1 over root 2, and yes, you could rationalize if you wanted to. If we did the same thing with 225, 225 is going to tell us to go 45 degrees past the horizontal for our reference triangle, 1, 1, root 2. Now, a different way to look at this one, a lot of people, when they draw these triangles, if we recognize that this is in quadrant number 3, if it's in quadrant number 3, a lot of people like to make both the x-coordinate and the y-coordinate negative. You choose to do it however you want to. If that's the case, we're in quadrant number 3 and I'm doing cosine, the adjacent is -1, and the hypotenuse is my root 2. 300 degrees. 300 degrees would tell us to rotate to about 60 degrees short of the horizontal, and again, remember, always a reference triangle comes off the horizontal. So fill your signs in. Here's a 1, here's a root 3, and here's a 2. The 1 would be positive, the root 3 would be negative because we're in quadrant number 4. If we're in quadrant number 4, cotangent, let's see, cotangent I don't know a lot about, but I know a lot about the tangent of 300. Instead, tangent of 300, let's see, that would be the opposite, root 3 with a negative on it, over the adjacent, which is a 1, and we'd have to put all that on the bottom of my fraction. Well, now dividing by a fraction is the same as multiplying, by its reciprocal. There's your cotangent. Last but not least, secant of negative 150 degrees. Negative 150 degrees would tell us now to rotate clockwise instead of counterclockwise. This time we're going to end up about 30 degrees short of the horizontal for that reference triangle. So here's my negative 1, negative root 3, and my 2. We're looking at secant. I don't know a lot about secant, but I know that would be 1 over the cosine of negative 150 degrees. Cosine of negative 150 degrees would be that root 3 with a negative on it over a 2. Again, we're going to have to put that on the bottom of a fraction, clean it all up. Negative 2 over the square root of 3.